Scaling deep learning from a single GPU to multi-node clusters isn't just adding more hardware, it fundamentally alters your code's architecture. The perceived simplicity of simply adding more compute often masks a significant engineering challenge orchestrating data parallelism, model parallelism, and mixed precision training across heterogeneous environments. Traditionally, this involved intricate boilerplate code, manipulating distributed data parallel managing process groups and explicit device assignments. The complexity escalated with gradient accumulation, sharded optimizers, and checkpointing strategies. This barrier meant significant engineering overhead before any actual research could even begin. Emerging Python frameworks like Hugging Face Accelerate radically simplify this. Accelerate acts as a lightweight wrapper, abstracting away the underlying distributed training mechanisms. It allows researchers to write standard PyTorch training loops, then with a single command automatically adapt them for multi-GPU multinode or even TPU setups. Consider training a large language model, perhaps a 7 billion parameter llama variant for a specialized legal summarization task. Manually configuring this across 8 GPUs, ensuring efficient data distribution and gradient synchronization, is a substantial undertaking. Accelerate reduces this to a few lines of configuration, allowing the same script to run seamlessly whether on a local multi-GPU machine or a vast cloud cluster using fully sharded data parallel FSDP. This stands in stark contrast to previous approaches where distributed training often meant significant refactoring. Introducing framework-specific boilerplate that tightly coupled your training logic to the distributed backend. Accelerate's minimal API design promotes portability, allowing researchers to focus on the model and data, not the infrastructure. The profound implication is the democratization of large-scale AI research. High-performance distributed training, once the domain of highly specialized ML ops teams, is now accessible to individual researchers and smaller groups. This significantly accelerates the iteration cycle, enabling faster experimentation with larger models and datasets. Ultimately, these tools redefine how we build and deploy AI. They shift the cognitive load from intricate distributed systems engineering to the core challenges of model development and scientific discovery. They transform scaling from a bottleneck into a seamless extension of your research workflow. References: Hugging Face Accelerate documentation, http Hugging Face, Codex Accelerate. If you want to support the channel, you don't have to cough, ihasambalaha.